Hey everyone, today I want to talk about nomenclature, which is the topic of Worksheet 3, this week's worksheet. Nomenclature just means naming, so the goal today is to learn how to name all of the chemical compounds that we might encounter in this class. So to do that, we provided you this flow chart to kind of work through what the different names could be, and this list of polyatomic ion names. So that are one of the things that makes up some of those compounds. So I'll show you how to use those in a second, but since it can be such a tedious topic for people, I want to go ahead and give you a little bit of history about how we arrived where we are today with naming. So many years ago, pretty much whoever discovered a new chemical could name it whatever they want. Just like you get a new cat, you name it whatever you want. My cat's names are Hero and Batcat. So why did we come up with those names? Well, we felt like it. So people did the same thing with chemicals, and they didn't know what they were, but as we discovered more and more about what they were, that they were related to each other, we thought we should come up with better names. And a few hundred years ago, this guy named Antoine Lavoisier, who was a Frenchman, who was an early chemist, came up wrote a book about this scheme, he said. He said, let's take these old names that were these, and let's replace them with new systematic names here. So these are all things that have the polyatomic ion sulfate in them, and these were the names they were calling them. And I can't even hardly read these things because they're so ancient names. Alum, which is not hard, argillaceous vitriol, ammoniacal vitriol salt, secret of Glauber's, ammoniacal vitriol, vitriol of antimony. And he said, let's change the names. Let's call this sulfate of magnesia or magnesia. I don't know, magnesia maybe. I think magnesium sulfate or sulfate of manganese, which would be manganese sulfate today. And so on and so forth. Let's say they're all sulfates of something, some metal. So that idea caught on, and we didn't stick with Antoine Lavoisier's naming, but eventually a group of chemists got together, fast forward to today, and they formed a union called the International Union of Pure and Applied Chemists, or the organization is the International Union of Pure and Applied Chemistry. So they wrote a few books about how to name different things, and this one is the book of Nomenclature of Inorganic Chemistry, and that's what we're going to be going off of in this class. Affectionately, this book is known as the Red Book. So you'll hear it referred to as just the Red Book. And it is a very long book about all the different ways you could possibly name inorganic chemicals. So just a quick little look, you can flip past the preface where it tells you all about what led to this book and why it was needed to be revised last, and get to the contents, and you can see there's a bit of a history, introduction history, some of the goals, and then some recommendations. Then we just get into the nitty-gritty detail, the grammar, what do we name elements, what symbols do we use, and it goes on, and you can see we're already into the hundreds of pages, so that by the end, before you get to the indexes, you've covered well over 300 pages. Because of that, I have no interest in printing that all out, so I didn't. I even used some lab books to fill up the stack. But we have read this, and we've tried to condense all of this information about how to name all of these different possible chemicals that could exist and condense that down into a simple system that we can teach you today in a reasonably short amount of time. So know that this is way simpler than really any time in history before now, and we can condense it down to a relatively short lecture for you to understand. Furthermore, on this video, I'm not going to try to tell you all of it, because that actually is what this worksheet is about. So this worksheet will take you through little piece by little piece about how to name. And the first thing is to understand the difference between molecular compounds and ionic compounds. So it's going to ask you that, and then it's just going to have you go through and list whether these are molecular or ionic with a couple little extra caveats thrown in there. And then it'll say, well, how are ionic compounds named? Let's break that down into pieces and talk about the different pieces of how that could be named. And then eventually write formulas for ionic compounds, and ultimately write formulas and names for ionic compounds. Then take names and convert them back to formulas. Then switch to naming molecular compounds. here, formulas, names. Then name acids, which is usually is a type of molecular compound, but is named sort of based on an ionic compound name. It's very strange. And then give you some more practice as we go. So it can be done. It is tedious, but we can give you the guidance, and this will guide you through all the different steps of learning how to name ionic compounds and molecular compounds and acids, which are all the compounds that we're going to encounter in this class. So let's talk about this flowchart. So the first step using this flowchart is trying to understand the difference between an ionic compound and a molecular compound. And that's the same way the worksheet starts. Ionic compounds are things like sodium chloride, for example, that have positive and negative charges repeating to make a crystal. And if you look very closely at a salt crystal coming out of your salt shaker, you'll see that it has a defined shape. And that shape actually, you definitely can't see it, but is made up of repeating positive and negative ions. Those ions are sodium ions and chloride ions. So that gives them different properties than molecular compounds, which are made up of individual units. So this overall crystal has a sodium ion and a chloride ion repeating over and over. But molecular compounds are made up of small units, like water, for example. We know is made up of 2 hydrogens and 1 oxygen, and that's just one unit to itself. It's not directly connected. It's not part of a crystal necessarily with every other water molecule. It's just one unit by itself, and it's able to move around freely. So that's what they are, but how can you simply tell the difference? Well, it's actually very quick and easy. Ionic compounds are combinations of metals with nonmetals. Metals with nonmetals. Molecular compounds have only nonmetals in them. So you can actually just look at the first element in a symbol. If it's a metal, you know it's an ionic compound. If it's a nonmetal, you know that you're dealing with a molecular compound. And then the naming builds from there. Binary ionic is where you're just combining 2 things, like that one we already talked about, the sodium chloride, the table salt, is sodium and chlorine together. Sodium has a positive charge, chlorine has a negative charge in the structure. And so you name them just like this. You name it, you put the metal name, sodium, and the nonmetal name, chlorine, except you change the ending to be IDE. And that's the basic name, metal, nonmetal, ide. There's a different group of metals that we call type 2 metals, the metals like sodium, which is here in this main group. We call type 1 metals. The ones here in the middle, up to the line, we call type 2 metals because they have variable charge. And there's an exception. There's a little triangle over here that we still call type 1 metal, and these are type 1. So the ones in the middle here are type 2, and they have variable charge. For example, iron can be a positive 2 sometimes, and other times a positive 3. So because of that, we have to be clear which iron we're talking about. Are we talking about the iron 2 plus that's going to be combining with chloride, for example, or the iron 3 plus that's going to be combining with chloride? So that's relatively simple. We just change those ones and put the Roman numeral for the charge after their name. 3. So that's the first step. So if I go back to the nomenclature worksheet, that's how we're going to be doing it. We're going to first learn that molecular compounds are made from only nonmetals. Then we're going to learn that ionic compounds are made from cations and anions, positive and negatively charged ions, that you can spot because they start with a metal atom. It would be a combination of metals with nonmetals. Then, of the metals, you can categorize them into type 1 and type 2. Type 1 are the normal ones that are in group 1 and 2 and the little triangle. And type 2, which are the ones in the middle section. Then there's a third class of chemical that's a part of nonmetals called acids, and these are easy to spot because the formulas start with hydrogen. So the first thing we're going to have you do is go through and just answer, is each chemical ionic, molecular, or an acid? And if it is ionic, what type of metal it is? So again, to decide, we just need to say, does it start with a metal? If it does, that makes it an ionic compound. Oops. Does it start with a metal? If it does, that makes it ionic. Does it have only nonmetals? If it does, that makes it molecular. Does it start with an H? If it does, that would make it an acid. And again, if it is ionic, then look at the metal and determine whether it's type 1 or type 2. So you'll go through the chart and say, look, this starts with sodium. Sodium is a metal, so that means I'm dealing with ionic. It's in group number 1, so that means it's a type 1 metal, so it's a type 1 ionic compound. It's an ionic compound with a type 1 metal in it. CO2, carbon dioxide, has carbon and oxygen, which are both nonmetals, so that makes it a molecular compound. H2SO4 starts with an H, so that makes it an acid. Of the acids, you have two different options, one that we call binary, which is just hydrogen and another element, or oxyacids because they also have oxygen in them. This one also has oxygen in it, so we'll call it an oxyacid. So that's basically how it goes. Just continue through the rest, looking to see if it's starts with a metal or a nonmetal. So this one is silver. Silver is a metal, so you're looking at an ionic compound. Then decide whether it's type 1 or type 2, depending on where it is on the periodic table or where in the metals group. So then it's going to go up from there, talking about once you've figured out what they are, then go on to how to name them. And you'll learn a little bit at a time about whether you have ions that are made out of multiple atoms. Then if you have molecular compounds, you'll flip to the next page. How do you name molecular compounds? If it's a molecular compound that starts with H, that's a kind of acid. How do you name those? So you should be able to follow through the rest of the worksheet. It'll build up to each one of those things and essentially follow the nomenclature worksheet as we go. So that said, it's time to get started. Enjoy.